Hello, this is Julian Cecil. I'm part of MEMS 5001. This is the optimization proposal, and I will be designing a FSAE radiator. In modern car engines, thermal energy stored in chemical bonds of gasoline is converted into usable mechanical work. However, no engine can perfectly convert all that energy into useful work. This results in waste heat that, if not properly removed from the system, will increase the temperature of the engine. It is dangerous to the engine if the temperature gets too high. Pistons can expand and seize the engine, components could melt, or the engine could misfire and punch a hole through the piston, seen on the right. These are all expensive catastrophes and render the engine useless. To combat this, an active cooling system is required to remove the excess heat. Most cars have one or more heat exchangers, also called radiators, that transfer heat from liquid running through the system to air flowing through the heat exchanger. Coolant returns around the engine and the cycle repeats. WashU Racing built a Formula One style race car that particularly needs an adequately sized radiator. In past years, the team used a radiator that was too small. The radiator couldn't keep up with the driver, and after a few abusive laps around the track, the driver had to stop and allow the car to cool down. The design goals for this season's race car is to design a radiator that can keep up with the extreme conditions on the track, while remaining lightweight and responsive. The ability to push the car harder and longer could mean the difference between first and second place. The radiator's performance is a complex function of surface area, engine RPM, due to the engine's crank-driven coolant pump, vehicle speed, coolant velocity, coolant fluid choice, radiator material choice, radiator fin density, and drag force. The purpose of this project is to find the optimum sized radiator. I want to minimize the difference in the radiator's performance and the engine's heat output. I also want to reduce the surface area, which means it's a lighter weight radiator. All of this will be determined with a genetic algorithm. This is important because the ability to push the race car harder and faster without overheating could win you the race.